Welcome back to Biology 160, Introduction to Anatomy and Physiology. Today we're going to be looking at the skeletal system. You'll notice this is one of the largest sections in your book, and there will be a number of recordings that we do about the skeletal system. In this first recording, we're going to be having an overview of the skeletal system to learn about some of the things we're going to be talking about in more detail later in this lecture. The first thing to talk about is what makes up the skeletal system. When you hear the term skeletal system, I'm sure the first thing that comes to your mind, the first thing that comes to my mind, of course, is bones, the skeleton. And that is the major part of the skeletal system, and that is where we're going to spend a lot of time talking. But then there are also other parts of the skeletal system, in particular joints, cartilage, and also ligaments. All of these are important parts of the skeletal system. We've talked about bones when we talked about different types of tissue. So let's tie these parts of the skeletal system back to the types of tissue we've talked about before. So think for a minute, what type of tissue category does bones fit under? If you said connective tissue, then you're right. So bone is a type of connective tissue. Cartilage. Think about cartilage and ligaments. They fit under a type of tissue as well, and that is also connective tissue. So bones, cartilage, and ligaments are all made up of all a type of connective tissue. That doesn't mean that we're strictly going to be talking about connective tissue, though. There's also epithelial tissue associated with bones and the skeletal system, as well as nervous tissue. And though muscle tissue isn't necessarily part of the skeletal system, there is muscle tissue associated with it, especially with the blood vessels. You're going to have smooth muscle, and skeletal muscle is going to be attached to the skeletal system. So going back to the skeleton, the bones are the most important part of the skeletal system, and we can take the skeleton and we put it into two different categories. We have something called the axial skeleton, and then also the appendicular skeleton. These are just parts of this, so these are two larger subdivisions of our skeleton as a whole. And we'll talk about these in more detail later, but just briefly, the axial skeleton is basically the framework of your body, the main part of the skeleton. So we're talking about the skull, the spinal column, and the hips, basically, and the thoracic rib cage as well. That's going to be your axial skeleton. It's in the middle. It's kind of the axis is what everything else is connected to. Then the appendicular skeleton, this is going to be basically your arms and your legs, your appendages. That's what makes up your appendicular skeleton. So you have your axial skeleton, we have our appendicular skeleton. Let's now talk about the functions of the skeletal system. We talked about this briefly at the beginning of these recorded lectures when we talked about a general overview of all the organ systems in the body. See what you remember about the functions of the bones. Take a minute, turn this recording off, and see what you can come up with. Okay, welcome back. Let's talk about the functions of bones. The first function that you probably thought of and most people think about is structure. So bones give us structure. And I remember hearing about this in elementary school, and you've probably heard this a number of times, but think about if you didn't have bones, what would life be like? So if we didn't have bones, I remember my teacher said that we would have to crawl around like we were slugs on the ground. We wouldn't have any sort of structure. And that's true. So we wouldn't be able to stand upright. We wouldn't be able to support ourselves without this kind of scaffolding inside our body that's made up of our bones. So structure is very important. Another thing you probably thought of is protection. So our skeleton protects our body, in particular our organs. So a lot of bones, though they do have muscle attachment as well, one of their major functions is to protect our body. Think about your skull. Its main job is to protect our brain. We have our rib cage that protects our vital organs, our heart and our lungs. Most of our organs have some sort of bony structure around them, except those in our abdominal cavity, where there are no bones there to protect. So that's a major function there. And then I'm going to put up here movement, because our bones provide a place for muscles to attach. If we did not have bones, if we did not have our muscles attached to bones, we wouldn't be able to move around very well. So it provides this lever system so that we can walk around and move. So our skeletal system and our muscular system are connected together very closely to allow movement to happen. Those are the three most, not necessarily the most important, but those are the three most commonly thought of functions of the bones, and those are very important functions, but those are not all of the functions of bones. There's a couple other important functions I want to talk about. The next one I want to put up here is storage. Hopefully you remember talking about storage before. So bones are a place where we can store things. In the inside of our bones, we have the bone marrow, which in adults is mostly made up of fat, so it acts as a fat storage. But then even more importantly, it's a storage center for the minerals of our body, in particular calcium. So we all know that bones are made up of calcium. Calcium is very important in bones. But our bones act as a storage place for the calcium in our body. Another term we talked about before is homeostasis. Our blood has to have a certain level of calcium in it at all times, and that can't fluctuate very much at all. So if it goes too low, that's a problem. If it goes too high, that's also a problem. And so as our blood is circulating in our body, as that calcium is being used up or is being lost, we have to replace that calcium to keep those levels the same. Or if we get too much calcium, we have to reduce the amount of calcium in our blood. And that's where the bones come in. So we have special cells in our bones that we'll talk about later. And their job is to either break down and release calcium into the blood, or they can do the opposite and take calcium from the blood and put it down as bone. So our bones are very active. We often like to think of our bones as being static, kind of the scaffolding that never changes, but they're always being built up and broken down, and we'll look at a few ways that happens in our body as we go through this lecture. And then the last thing is blood cell formation. So our red blood cells in particular do not last very long. So maybe about 3 months from when they become mature until our blood cells are broken down, they're no longer used in our body. So our body has to constantly be producing more red blood cells, new blood cells, and then also our white blood cells for our immune system. And so this blood cell formation also happens in bones. And we have a special word for that, and I'm going to write it here. Hematopoiesis. This is the term for blood cell formation, the technical term, if you will, for blood cell formation. So you can see our bones have a number of very important functions that without these functions happening in our body, we would not be able to survive. The bones in our body come in many different sizes and shapes, and they have different functions, but all together we have 206 bones in our body, and this is in the adult skeleton. As a child, you're going to have more than 206 bones, because as you grow, some of these bones fuse together and different things like that. But as an adult, we have 206 bones. That's a pretty good number of bones. They range in size from our femur in our leg, which is could be about 2 feet long, very large, heavy bone, down to the bones of our inner ear, which are very, very small, not microscopic, but about the size of the smallest bone there, about the size. Try and think of something good to compare it to, but a couple grains of rice about. So very small bones, and they have a very specific, important function. So we have lots of different bones, but all of our bones come in two main different types, and many of our bones are made up of both. We have what's called compact bone, and we also have spongy bone, and you've probably heard of these both before. So compact bone is called compact because it's very homogeneous, we call that, meaning that it's even, it looks even throughout. You can't see holes and it looks very uniform. And here we have some compact bone. So notice it looks like one solid piece of bone. And when we look at the microscopic anatomy of bone, we'll see that it's not necessarily totally solid, but compact bone is called compact because of that. Very strong. Spongy bone, on the other hand, is not uniform. It's made of these interconnecting small needle-like pieces of bone, and there's a lot of open space in spongy bone. So here we have our spongy bone. Notice all the open spaces here, all these little projections. It doesn't look as strong as compact bone, and to a certain extent it's not, but spongy bone is also very strong. So it's made of bony material, and what you find is that where the stress is being put on the bone, that's where you're going to find these little projections going through. So it acts like a scaffolding again. So within our bone, we have these little scaffoldings as well. So if you think about, if you've ever been up in the roof of a house, so the roof of your house is able to be, the roof of your house is held up by these trusses, and trusses are not solid. Looks something like this. You have this truss with the main frame on the outside, and then you have these pieces of wood going through. And I mean, this is not an exact drawing, of course, but it gives you an idea. So the truss doesn't have to be solid, but you have these supports coming in at major places that the support is needed, and so you're able to hold up the roof of your house. Spongy bone, the same. So even though it's not solid, very strong, and it's able to withstand a lot of impact. So there's different types of bone tissue inside our body. Now let's look at different bone categories. So all of these 206 bones in our body, we can put into 4 basic categories. And they are put in categories according to their shape, basically. So you have what are called long bones. And this is just what it sounds like. So long bones in your body are the very long, thin bones. So all of your arm bones are going to be long bones. So your humerus, your radius, your ulna, your femur, the bones of your leg, these are all going to be your long bones. Okay, we have what are called short bones. Short bones are short, and they're usually squarish type bones. And so the bones of your wrist are going to be short bones. The bones of your ankle as well are going to be short bones. After that, you have your digits, bones of your digits, which are going to be long bones. Another type of short bone is found right here. Your kneecap is a short bone. And this short bone has a special name. We call this a sesamoid bone, because it is found between 2 ligaments. So you have a ligament attaching the patella, or your kneecap, to the femur, and also a ligament to the bones of the leg. And so this is found in between. It's totally surrounded by these ligaments, and so this is called a sesamoid bone. Next we have flat bones. And flat bones are named flat because they have 2 layers of compact bone with spongy bone in between. They're very flat. And then also our ribs are going to be flat bones as well. And so they're not long bones, they're flat bones. And then any bone that doesn't fit into one of these 3 categories we've already mentioned, then we just call these irregular bones. And our irregular bones are mainly going to be our vertebrae here, and then our hip bones also. Those are irregular bones. They don't fit into any of the other categories that we have. And those are a type